Welcome everybody. In today's class we are going to be learning and understanding about the box plot. It's also called as a box and whisker plot. Now foremost, let me draw the number line, which is very important. Now we have the following data: the teachers appointed or teachers working in a certain school and their experiences. So this is the information that is being given: 10, 12, 11. So this is the experience given for the teachers working in a school. Now the management wants to appoint a principal for the school, and it is looking out for the teachers who are experienced, and they collect the data and they would want to analyze it. The same concept which I'm teaching you is actually applied greatly in financial engineering, specifically in the stock market. Suppose you want to study the stocks of companies, then there too you have extensive use of the box plot. So having given you that initial motivation, it is imperative that you understand this concept fairly well. So what I'm going to do is, foremost, get the data and you arrange the data in increasing order. Step number 1, you arrange the data in increasing order. Okay, that is the step that you will have to follow. So I'm going to write down the data given. So the first smallest number that I have is 10. The next one I've got 11. So just cancel this up. So you got 11 here. I'm going to write that 11, and then you got the next 11. I'm going to write that 11. So cancel this off. Then you got another 11. So all these 11s are exhausted. So 17 and 22. So I have written them in column fashion. It's always easier to manage data like that in column, because ultimately you are going to be utilizing softwares, right? If you're using Excel, everything is in column. What you need to do is you need to first count the number of data points that you've got. So step number 2 is find the number of data points you have. When I say points, I mean the data. So you got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So you got 12. Now after finding this out, in step number 3, you divide this into 2 halves. So this is going to be 6. Now, so 1, 2, 3, 4, 5, 6 is over here. Then 1, 2, 3, 4, 5, 6. So you got even number of data points. So this is the midpoint. Now whenever you have an even number, what you got to do is, now 6 is present here, take the value 1 above 6 and 1 below 6. So that is going to be my step number 4. So let me reiterate the step 3. Take the data point and you divide it by 2 and you will get the value. Now go and locate where that line falls. So draw that line and then collect the data. Since it's an even number, this is an even number. Now take the value 1 above that line and 1 below the line. So this is going to be 12 with 13. You divide it by 2. So 12 added with 13 is 25 divided by 2, and 2 divides 25 one time, and 2 divides 5 2 times, and you got a remainder there. You add a 0 and you get 12.5. So what exactly is this 12.5? This 12.5 is called as the median value. So our median, since I told you about dividing by 2, is actually located over here. And do you know what we call that median? we call it as Q2. And what is Q2? It's called as the second quartile. Now after you got the second quartile, go above and count the number of values. 1, 2, 3, 4, 5 and 6. So you got 6 here. Now you have to find the median for the above set of values. So usually what I would tell students is, if you have a set of data like this and you are interested in finding the median, just strike the above value, say strike this value against the last value, second value against the second last value, the third value against the third last value, and so on and so forth. So ultimately what you are doing here is, in this case, since it's even in number, the number of data points are even in number, you are left with 11 and 11. You can't cancel these two out. So in this case you got two 11s here. Usually it might not be like this, but there is also a probability that you will have two like numbers. But it doesn't matter whether you have the same number or different number. Now what you have to do is, you have to block this off and go over here, take that number. This is your step number 5. Take the number that you have got. I got 11 and 11, and you divide by 2. Now 11 added with 11 is 22. You divide by 2, you get 11. Now this is called as the first median or the first quartile. So we represented this value as Q1. Now this value is represented as Q2. So this is where we got the first quartile, Q1. So you can call it as first quartile. And what is the value that we have got? The value that we have got is 11. So I've got Q1 and I've got Q2. Now go below this line. If you remember, I had mentioned to you that you need to draw this line where you're able to locate the value after dividing the number of data points by 2. Now you go below that line and you will find a sequence of data points. Now you need to find a median for this. Now this median is called as Q3, but let us just exhaust the value. So you cancel this against this versus this, and ultimately, as I mentioned to you, you are actually getting two values. So you can't cancel these two values. Now if the entries are odd, you will be left with 1 point. So that would become ultimately your median. So take this is the next step, step number 6. The values that you got, 14 and 15, you divide by 2. This is 29 divided by 2. So that is going to give you 14.5, and you call it as Q3. So this is called as Q3. This is the third quartile. Right? So I have got the quartiles. Now after you have got the quartiles, your next step number 7, you have to locate the minimum value. Now of course some of them will start with the minimum value, but I find it better to get the median first and then go on. So the minimum value for the data points is important. So we have arranged the data in this fashion, right? So clearly you can find this is going to be my minimum. So take the minimum value, place it there, and then I am moving on in this fashion. Go to step 8 and find the maximum value. Clearly the maximum is going to be 22, but don't be in a hurry to locate the maximum, right? So just leave the maximum for now. We are going to be coming back because you might be prompted to immediately place 22 as your maximum, but don't do that, just wait. Now what I should now do is, I would like to go and plot the quartiles, or I would say plot the box and whisker plot. So just to go up over here, foremost you have 10 to be the minimum values. So go and place a dot, plot the point 10. As I mentioned to you, the maximum, we have got two maximums here. Okay, I would say 22 and 17. The reason I'm not plotting it, you will understand within a minute. Okay, now next is go plot your median, the real median, Q2, that's the second quartile. What is the second quartile we have got? Q2 we have got it as 12.5. So go up here. 12.5 is located between 12 and 13. So this is going to be my Q2, right? So you don't have to write it now, so I'm just placing the point there. Next we need to go and get Q1. Where is Q1? Q1 is 11, right? So go and plot Q1. So this is going to be my Q1. So we need to have a box there. So the box is actually starting from Q1. So just draw a line there. And the Q3, what is Q3? Q3 is 14.5. So 14.5 is located between 14 and 15. So this is my 14.5. Approximately, I'm just drawing an approximate 14.5. Okay. So now you complete the box. So my Q1 and Q3, they are going to be my actual boxes, right? So I will just place Q1 here, Q1 and my Q3, and this middle value, this is going to be my Q2. This is going to be my median, right? So now you have to draw the whisker. So just connect the minimum to the box. Okay, so that is connected. Now, as I mentioned to you, don't be in a hurry to draw the maximum. Why? Because we need to find the all important value, what is called as the interquartile range. This is very important. Now why this is very important? Because this helps us to find outliers. Now what do you mean by outliers? I'm going to explain it to you within a minute. So foremost, let me get the formula for interquartile range. The formula is Q3 negative Q1. This is the formula for interquartile range. So Q3 14.5, and what is Q1? Q1 is 11, and this is going to be 3.5. So my IQR is equal to 3.5. You can put a box, you can box this result. Now you might be wondering, why do we need this IQR? Now you know why do we need this IQR? We are going to find, as I mentioned to you, outliers. Now what is an outlier? Now outlier will be that particular value which has the power to sway the mean, right? Now what is the mean? Mean is the average entry, right? Now if you have, say, 20 employees salary and you are finding the mean, and you are finding the average salary to be $5,000. Now suddenly there is a CEO coming into the frame, and his salary is, say, 100,000. Now if you were to put this 100,000 and find the average salary of the employee, do you think the average salary is going to be 5,000? No, the average salary would be far more greater than 5,000. So what is the meaning of this? This means that this particular entry that you are placed in actually giving us a wrong picture. What is the wrong picture? You are getting an impression that this particular organization, say some organization by name called, say, N, or some organization called P, is paying its employees really good. Okay, because in this day and age, 5,000 is okay. You can just survive in $5,000. But when you add this $100,000, you are getting a mean that is literally, skyrocketing, and that is giving us a picture, a wrong picture, as I mentioned to you, that this particular organization is really paying good. It's to its employees. So what we have to do when we are analyzing this data, we will have to get rid of the outliers. So the question is, how are we going to get rid of this outlier? That is an important point. So there is a formula for that. So the formula is, you take Q3 and you add 1.5 multiplied with IQR. Now if this value that you are getting, you go to the data and you compare the value. Now if the value that is present in the data is greater than this value, then you drop the data. Okay, that's the idea. So let me take Q3. What is Q3? Q3 is 14.5. So place that 14.5, place that 1.5. So what do we get as IQR? 3.5. So take your calculator and you multiply 1.5 with 3.5. What do you get? You get a value of 5.25. You add 14.5. What do you get? You get 19.75. So the outlier, any value or data greater than 19.75 is deemed as an outlier. So you drop the value from the data, drop it from the data set, because that is not going to give you a clear picture. So in this case, you go back to the data and you clearly see that 22 is greater than the outlier's value, the cutoff 19.75. So what you need to do is just go here and place a dot over here. Place a dot. So now what is the maximum here? That's the reason I said reserve the maximum for last. So the maximum is going to be 17, right? This is the data point. So go up over here and plot 17, and you make sure to draw the line. So probably I should have, okay, I should have, okay, so that is going to be my value. So I will just write the max and min. Okay, and what is this? This is going to be my outlier. So this is for the maximum entry. So now we need to find the minimum value for the outliers. So what I will do is I will utilize this part. So for minimum value, you need to take Q1 minus 1.5 times IQR. So what is Q1? Q1 is 11. So take that 11 minus 1.5 times 3.5. This is 11 minus this value. We have got it as 5.25. So 11 minus 5.25. So 5.75. 5.75. So any value that is less than 5.75, go up to the data. Do we have an outlier? So 5.75, any value that is less than 5.75 should be omitted. Now we got our value starting from 10, so definitely 10 is not less than 5.75. So we have no outliers on the left end, but we have an outlier on the right end. Now what does this information that we have got gives us? Now there are two ways that we can actually interpret this result. Now as I mentioned to you, there is a school, right? We got a list of sequence of employees with their experiences, and a principal has to be appointed. Now there is a person with 22 years of experience. Now the management wants to elect a principal. Now there are two things. One, from this information, clearly 22 is an outlier. So outrightly the management can think, yes, this person has got good experience because he or she has the most level of experience, and this person is definitely will be an asset to the organization for the fact that with the experience there will be expertise, right? Now with the expertise, the decision made by the individual will be far more balanced. So for an educational institution, it is imperative that you have experienced people on the top, thereby balanced decisions can be made. So for sure this person can or has the potential to become a principal. So that is one particular decision. Now on the other end, if the organization wants to have a principal who is very, very active or very dynamic, no, definitely, because given the age, as I mentioned to you, the level of promptness would also be balanced. Everything would be balanced in this case. So you won't have any sudden flights. Now, if you want someone to be very, very active, enthusiastic, I'm not saying that people with 22 years of experience will not be active and enthusiastic. I'm just giving you the picture. So certain organizations which are literally growing would want the principal to go about in securing, say, financial supports. So to get any form of financial support from any private bodies or any organization is not going to be an easy job, right? So you have to keep on writing emails, say every day you have to be posting, say 300 to 1000 emails, and then you have to go and meet people. So in situations like that, people who are younger, who have experiences, who have both, who have the advantage of being highly mobile or mobility and the experience, they would be an asset. Specifically if you have to have a principal who has to do a lot of running. So I'm not saying people with higher experiences cannot do that, but there is always that element which the higher organization would take into picture. So depending upon what they want, for organizations which are mature, they don't need financial support from anybody. They are capable of running their show. So for organizations like that, they would always go for people who are very balanced, experts, who have expertise in the area and who are experienced, because they want the flow to be very, very smooth. Right, so you won't have ad hoc decision making in these cases. But in cases where you need a principal to go about writing 300, 400, 500 emails and going to people and asking for financial support and other supports for the school, specifically a growing school, then they would always focus on this. Okay, now I have given you this information. Now there is another information you need to know. Now between the minimum value and the first quartile, you will have 25% of the data distributed. Between Q1 and Q2, this is very critical, you have another 25% distributed. And between the median and Q3, you got the next 25% distributed. And between Q3 and the max, you got the next 25% distributed. Now, why am I giving you this? This is very, very critical to also analyze data which are having a different level of research question. So in this case, the research question is to locate the principal. So I've given you the solutions for both sides and we have discussed, but there is also other side of the questions where we would want to know the distribution of the data. So this is the first 25% of the data will be present between the minimum and Q1. So this also goes to show that if you are taking 25% of the data, the experience levels will be between minimum. So what is the minimum value we choose? The minimum experience is going to be 10. And what is Q1 is 11. So between 10 and 11, 25% of the data will fall in this group. So do you want to choose people from this range to be an head? It's up to you. When I say up to you, it's up to the organization. So this is again a different way to divide and segment and analyze the data. So I hope you understood this particular class, and if you have any questions about the box and whisker plot, this is a very important concept and this will be utilized on and on and on in our study, in our statistical study on data analysis. So thank you everybody. Until we meet again, please like, share and subscribe to our channel. Have a nice day.